Hello there, welcome to CXC Math TV. And today we're going to be looking at kinematics, which is motion in a straight line. And so let's consider this example right here, right? When we hear motion in a straight line, before we look at the example, we always talk about distance, time, and velocity. That's what we'll be talking about a lot in this topic. Now, distance, how far an object travels, right? That is distance. And it doesn't depend on direction. So for example, this ant right here, right? This ant is crawling along the ruler. It crawls what? 3 centimeters forward. So we'd say that the distance the ant crawled was 3 centimeters. Now look at this right here. The direction doesn't matter. If the ant started at 3 centimeters and then was crawling to the left, right? It crawled 3 centimeters back to the left, back to the origin, right? We'd still say the distance is 3 centimeters. So realize that the direction didn't change the answer. Now, since the direction did not change the answer, look at this now. Distance does not depend on direction. Distance what? Does not depend on direction. Now, let's follow the ant again. So the ant got 5 centimeters forward and then it went 2 centimeters back, right? I know it disappeared. I'm going to try to let you see it. We got 5 centimeters forward and then it gonna go 2 centimeters back. Oh, my bad, I didn't put in that animation, but just follow the arrow, right? So the ant go 5 centimeters forward to here, and then afterwards the ant finish right here, right? Now what is the distance that the ant walked this time? Well, the ant went all the way out here, 5 centimeters forward, then 2 centimeters back. So the distance the ant traveled is 7 centimeters. However, what is the displacement? Look at this now. The displacement now is the difference between an object's final position and its starting position, right? So displacement does, the direction does matter. So it's really your final position minus your initial position. So we're going to go back to the ant example again, right? So with displacement, direction does matter. So we have to take into account whether you're going north, south, east, or west. So for example, right, the ant walked 3 centimeters, then its displacement is also 3. Look at this. Let's go back to the example, right? The ant walked 3 centimeters, and then that's positive 3 displacement. Notice we put a positive sign in front of displacement, right? Now look at this. If the ant does this now and walk back to the origin where it started, the distance is 3 and the displacement is negative 3. Why is it negative 3? It's always what? Final position 0 minus initial position 3. So we get negative 3 to be displacement. Now that might not be so clear. So let's look at it with another example here. So remember when the ant went 5 centimeters forward, then 2 centimeters back. We said that the distance was 7. Now its displacement is just positive 3. The displacement is just what? Positive 3. It is final 3. Look at it, you know. It's from where it started, from 0, right? From 0 to this positive 3, that's its displacement. Now what I'm going to do is I'm gonna utilize a track event. It's always easier for me because I love track and field to use track, right? So let's say we're gonna run a 100-meter race, right? Let's shorten it, 50 meters. I'm not fit enough to run 100, right? So let's say we're gonna run a 50-meter race. This is Bertha and this is Owen, right? So Bertha, she's gonna race Owen. This is Bertha, and Bertha runs. And while Bertha is running, right, we realize that Bertha, her hat fell off her head, right? Her hat fell off her head and blew away, and it blew 20 meters behind her. At this point, let's say she had run 20 meters in the race, then she ran back 20 meters to pick up her hat, and then she ran back Right here again, another 20 meters. In that case, look what we're saying. Bertha run, first Bertha run what? First Bertha had to run 20 meters from the starting, right? She run 20 meters from the starting. Look at this, 20 meters. Then her hat blew off to 20 meter behind her. So 20 meter behind her mean after Bertha run 20 meter forward and then run back 20 meter right here and then run another 20 meter. It's really 40 meters behind you running total. So after Bertha run 20 forward and 40 behind, so far she run what? 60 meters. But after running 60 meters, she run 20 meter back to the start position, which is 80. Another 20 meters forward to right here. So in total, Bertha run 100 meters in total. But look at this. Bertha runs 100 meters in total, but in comparison to where the race started, she only run what? 20 meters. So this is the start point. And really and truly, Bertha can't tell the people and say, listen, I run 100 meters, I double the distance. No. Bertha, you only run 20 meters because displacement deal with where you're starting from. Where you're starting from is key. So if Bertha is right here, she only ran what? 20 meters. If Bertha run to right here, she only ran what? 20 meters. So I hope that made sense with displacement for you. Alright? Here's an example. An athlete runs around a 100-meter track 3 times. What is the athlete's distance and displacement? So look at it. Running around the track. Sprinting. There we go. Usain Bolt. First 100 meter in 10 seconds. The next 100 meter in another 10 seconds. That's 20. Now Bolt start to tire. And look at him go. Usain Bolt, that's 31 seconds to run 300 meters. That would be his distance. So his distance is 300 meter. What's the displacement? He doesn't move from the starting point yet. So the displacement is what? Zero. The displacement would be what? Zero. Because it's from where he started. The displacement is zero. Why? Why is that? Answer that question. Now, I hope you'd have understood everything there with distance and displacement. The next thing to talk about is speed. Now, speed is just the rate at which an object is moving. So, in other words, it's distance divided by time. Speed is what? Distance divided by time. Sometimes you'll see them use the letter V. So V is equal to distance divided by time. And oftentimes you'll see them use the letter, instead of D, they'll use S. Right? So likewise, speed does not depend on direction. So for example, a car drives 100 meters in 5 seconds. You see it there? The car is driving 3, 4, 5. The car drives 100 meters in 5 seconds. What we do say is that the speed of the car, as we say, the car drives 100 meters in 5 seconds. There we go. Zoom. That's pretty fast, right? So in driving 100 meters in 5 seconds, we can say on average the car speed is what? Distance divided by time. 100 divided by 5 is 20. What we're saying is, in other words, every 20 meters, the car covers in 1 second. Does that make sense? So in 5 seconds, 20 times 5 is 100. So every second the car is driving 20 meters. So if we tell you this now, a rocket is traveling at 10 meters per second. How long does it take the rocket to travel 30 meters? No problem. You just sit there, that's the rocket. Zero. Rocket shoot by at that speed. How long it gonna take it to cover 30 meters? You're just gonna use the formula. The formula tells us that the speed is equal to distance divided by time. And so 10 is equal to the distance of 30 meters over the time we need to find. So we can cross multiply to say 10 times t is equal to 30. The t is equal to 30 divided by 10. which is 3. It would take 3 seconds for the rocket. So you see the rocket? Let me show you the rocket. See the rocket here? It would take 3 seconds for the rocket to blow by in 30. To go at 10 meters per second to cover 30 meters. That's all. This question now. It says a race car is traveling at 85 meters per second. How far does the race car travel in 30 seconds? You see race car here? Zoom. And it gone. See it here again? Zoom. How we gonna do that? We're gonna set up the equation again. Speed is equal to the distance divided by time. So if the speed is 85 meters per second and the distance is what we don't know, and they want us to figure out how far it's going to travel in 30 seconds. 30.0, right? So all we have to do now is cross multiply. So 85 times 30 is the distance. Now you work that out. 85. All I'm going to do is work out 85 times 3. 3 5 is 15. Bring up 1, 24, and 1, 25. So it would travel 2550 meters. That's the distance it would travel in 30 seconds. So this car is flying to cover that much distance in 30 seconds, right? The car is flying, but that's fine. So now the next one we need to talk about is velocity. Velocity is just speed with direction. So velocity is displacement divided by time. So remember, speed is distance divided by time. Let me write it down here. Remember, speed is distance divided by time. And this doesn't consider direction. Direction doesn't matter with speed and distance. But with velocity now, it's displacement divided by time. So with velocity, it has a magnitude and a direction. Later down in the syllabus, we call it vector quantity, but we'll talk about that another time. So here's an example, back to the ant example. Look at it. So the clock is going down. See there, it takes 5 seconds for the clock to cover what the distance being 7 meters down. So the distance traveled is 7 and the displacement is 3. Now look at this. If you wanted the velocity or the speed is distance divided by time. Always remember, speed is distance divided by time. So we divide 7 by 5, we'll get 1.4. But if you want the average velocity, that would just be 3 divided by 5, which is 0.6. Notice velocity and speed are different. Alright, and now we're looking at some exam style questions now. And so as we can see right here, it says here is a distance time graph for Charlie's journey over the course of a day. Right? So of course we've covered everything in displacement and velocity. Right? And now of course when you get exams, this is how it's going to be. Right? It's going to be a little bit different from how we would have went through the notes. So just to go back again, here is a distance time graph for Charlie's journey over the course of a day. Right? And the graph goes further and explain what Charlie was doing for the day, right? Now it says, describe each stage of Charlie's journey as represented by the graph, making sure you make mention of the following. The distance traveled in the first part of the journey, the speed traveled after the first stop, and the direction of the travel at 2 p.m. So let's go ahead and do that. Now, the first thing I want you to observe is what was happening in the first hour, right? So look what was happening in Charlie's journey on the first hour. So in the first hour, notice Charlie covered what? 6 miles. So we can write in the first hour from 9 to 10, Charlie covered 6 miles, right? So in the first hour, Charlie covered 6 miles. You can even go ahead and tell them maybe average speed. His average speed then is 6 miles per hour in the first 1 hour, because that's what he did. Now then, what did he do next for the next 2 hours? For the next 2 hours he rested. Rested meaning he was not moving. For the next 2 hours, he was not moving. So maybe Charlie look for Keisha and Charlie stop at Keisha's house, and him just go and chill with Keisha for 2 hours, right? So for the next 2 hours, notice the distance is not going up. He's resting, right? So for the next 2 hours, Charlie rested. Then now at midday, so 12 o'clock now, at midday now, what did Charlie do? Charlie traveled 4 more kilometers. At midday, Charlie traveled 4 kilometers in 1 hour. Right? And then what happened at 1 o'clock? At 1 o'clock, he made another stop. So Charlie might get hungry and he say, all right, let me go buy some KFC. So at 1 p.m., Charlie rested or not moved for another hour. Alright, so far we covered the first part of the journey. Now it says the speed traveled after the first stop. Right? So we did make mention of the speed. The same traveled 4 kilometers in 1 hour. That is the speed, 4 kilometers per hour then. Right? Now after which now, right, so we're at this point. So we're at 2 o'clock now. We need to describe this. Realize that it's going down now, right? So that means Charlie reverse his direction. So Charlie now at 2 p.m. is moving in the direction back to home. And after he was moving in the direction back to home, he what? He traveled. Now notice him go 1, 2, 3, 4 kilometers in the next hour. So he traveled at a speed of 4 kilometers per hour. Oh, I keep saying kilometers and it was miles the whole time. So guys, my apologies. I'm just gonna I'm just talking about kilometers the whole time. It was supposed to be miles. So just change the question from miles to kilometers since I was talking about kilometers the whole time, right? So let's change it to kilometers. So Charlie is traveling at 4 kilometers per hour, right? Going down, right? For 1 hour. Then finally at 3, see here now at 3, he then changed direction again. You have to make mention of that. He changed direction again, right? And then he did what? He traveled 9 kilometers in 2 hours. So he then traveled at a speed of 4.5 kilometer per hour for 2 hours. That's what he did. Then after he did that, what did he do? Right? So then at 5 p.m., he changed direction again. He changed direction again. So I'm going in the reverse direction again. Right? Traveling at, notice this is 1, 2, 3. So that is 3 kilometers per hour for 1 hour. And that's what Charlie did. That described his journey. I know I didn't write it as smooth and as pretty, but that's fine, right? We get the basic idea. Nice. Now this question right here, number 2, I want you to pause the video and attempt this question. It says Katharina and Julia are both competing in a long distance race. The distance they both traveled from home is displayed on the chart. Who covered the longer distance on the race? So who covered the longer distance? Pause the video and attempt this question. Alright, let's go. Now, as you pause the video, I hope you have wrote an answer. Now, who traveled the longer distance? None of them, look. So, the dotted line is for Julia. Julia covered how much distance? 16 kilometers. And then the continuous line is for who? That's for Catherine. And Catherine covered what? 16 kilometers. So, they both covered 16 kilometers. Hence, none covered more. Alright, my grammar is not the best. I'll leave it at that. They both covered 16 kilometers, so that is, they covered the same distance. That's it. Nice. Let's hear what they have to ask next. So now it says, what was Catherine's highest speed over the course of the race? And how much time did Julia spend ahead of Catherine? Go ahead again, pause the video, attempt the question for me, please. Pause the video and attempt the question. Alright, so as you pause the video and you're going to attempt this question, what do you notice? What we do notice is that they want Catherine's highest speed, right? Always remember, speed is what? Speed is equal to distance divided by time. That's what we said. Speed is distance divided by time. So we need to look at when is Catherine's speed the greatest. That means when is the gradient the steepest. Let me say that one more time. On the y-axis is distance. On the x-axis is time. Speed is distance divided by time, which is gradient. The gradient would give us distance divided by time. So we're looking for when is the gradient the steepest for Catherine. That will tell us our highest speed. Notice right here, the gradient for Catherine would be what? Alright, so right here, if you were to find the gradient, you will realize that the gradient would give us the speed. So this portion, the speed would be 4 miles over 1 hour. So for this part, the first hour, she's traveling at 4 miles per hour. 4 miles per hour, right? Now, right here, so when it's a horizontal line, her speed is what? 0. So right here, so she's not moving, the speed is 0. Now, going up now, 2 miles per hour, right? So we notice that this is 6, this is 4. So the gradient would be 6 minus 4 over 1. So right here, so her speed is 2 miles per hour. Now, the next portion, let me change the color. This in the purple spot right here, this right here, the gradient would be what? Notice the y2 is 12 and y1 down here is 6. So this right here is 12 minus 6 is 6. So this is what? 6 miles you covered in 1 hour. Notice you go from 6 to 12, so that's 6 miles in 1 hour. Now the next portion, let's do it in black. We notice that she went up 4 miles, right, in 1 hour. So what's her greatest speed? Her greatest speed, Katharina's highest speed, was 6 miles per hour. That was her greatest speed. That's it. Easy. And it was done between 1 to 2. Next part, it says, how much time did Julia spend ahead of Catherine in the race? How much time? Now, we have to use the graph, right? So, when was Julia ahead of Catherine? So, I'm going to erase these markings just so we can, see the graph better. So, when is Julia ahead of Catherine? So, Julia is ahead of Catherine when you realize the dotted line is above. The only piece where the dotted line is above is from right here. Let me put a dot. It's from right here to right here. This is when Julia is ahead of Catherine. So notice Julia is ahead of Catherine what? 1 hour, 2 hour. Now go looking at the graph, it goes 1, 2, 3, 4, 5, right? 5 right here. 5 units, right? So in the middle we know is 1, but if it each hour have how many minutes? Each hour have 60 minutes. And if you divide that by 5, then each division is 12 minutes. Right? And so right here, this is 12, 12, and 12 is 36. So if we're going up, let me go up and make sure I'm telling you the right thing. Sorry. So right here would be 1 hour to spend ahead. Right here is 2 hour. Then at this part is two divisions going across. So how much time did she spend ahead? 2 hours and 24 minutes. Oh, we can see the 24 minutes clear, right? And that is it. So Julia was ahead of Catherine for 2 hours and 24 minutes, right? And then realized Catherine finished the race from 3 o'clock and Julia finished all the way at 5 because Julia was just traveling at a constant speed. Catherine stop, sprint, stop, and all of that crazy stuff. Now, question 3. Question 3 seems interesting. Another distance time graph. So notice we're doing a lot of distance time graph questions first, all right? No problem. So this distance time graph, it says, on the diagram, draw a distance time graph to represent the information. Rain starts 4 miles from home. So notice she doesn't start at home, she starts what? 4 miles from home and jogs away at 6 miles per hour for 20 minutes. Now 6 miles per hour, right? First thing is she's going at 6 miles per hour for 20 minutes. So what was her distance? You have to first remember what 20 minutes is equal to 1/3 of an hour. Right? 20 minutes is 1/3 of an hour. And then now you can say, but remember, speed is distance divided by time. So remember, speed is distance divided by time. So if you want to know the distance you actually covered right here, so let me write it again. I think I can write it here. Speed is distance divided by time. You have the speed and you have the time. So the distance is the speed times time. So in that case now, 6 times 1 over 3 is just 2. In other words, they're telling you that I'm going to draw the information. So she started 4 miles away from home. This is at 4 right here. Started 4 miles away from home and jogs at 6 miles per hour for 20 minutes. Up to 20 minutes, she's going to end up reach 6 miles away from home. After 20 minutes, she's what? 6 miles away from home. Why is it 6? Remember, we just worked out that in that 20 minutes, she covered 2 miles. So we add 2 to the 4. She was 4 miles away from home. Then we add 2 more to it. Now she's 6 miles away from home. Now it then says she runs away from home for 2 miles, taking 10 minutes. So now she gonna run another 2 mile. She run a further 2 mile away from home, taking 10 minutes. So this is where the graph reached now. Then it says she rests for 10 minutes. Resting means as time go by, the next 10 minutes she's not moving. So notice for the next 10 minutes she's what? Not moving. So notice we covered this, and we covered this. It then said she then takes the bus to the shop 8 miles further away at an average speed of 24 miles per hour. Now they didn't give us the time this time, but no problem. They gave us the distance and the speed. Speed is what? Distance divided by time. So if you need time, time is distance divided by speed. You have to transpose a lot in mathematics. So the distance, 8, divided by the speed, 24, that is 1/3. That's 1/3 of an hour. But an hour is made up of 60 minutes, so we multiply it by 60. So we get 20 minutes. So what they're telling us is that she traveled 8 miles in 20 minutes. So now we can construct that. She traveled what? This is saying she traveled 8 miles in 20 minutes. So 8 and 8, I believe that is 16. And she going up this fast because she's on the bus now. Then now it says after shopping for 10 minutes, so remember when she at the shop, right, she not moving, right, she just in the shop. So after shopping for 10 minutes, she returns home at an average speed of 32 miles per hour. So she's at the same position now for 10 minutes. She's in the shop, and then now it says she returns home. After shopping for 10 minutes, she returns home at an average speed of 32 mph. Okay, so I guess what they want us to do is, let's take that off. They want us to say, all right, so this is a 10 minutes that you use to shop and end up return home. All right, so now what they're giving you is the time. They give you the time and the speed, so you need to work out the distance, no problem. But remember, distance, we had wrote it down here, was velocity times time. All right, so velocity times time. So you work out now 32 times the velocity times time. But 10 minutes, you have to put it, remember, it's really out of hours. So 10 over 60, that's it. Right? So the next 10 minutes, she return home. This is the distance that she traveled returning home. This is 5.33. Right? So returning home now, the direction is going to change. It's going to go down. The direction is going to go down. Alright, direction is gonna go down. Alright, so afterwards, as we said, she shop for 10 minutes right here. So this is 10 minutes of shopping. And then after shopping for 10 minutes, she traveled at an average speed of 32 miles per hour returning home. Returning home means she go back to the origin, but we need to now work out the time. How far is she away from home now? The distance she's away from home is 16. So we know that 16 is the distance and the speed is 32. So now we need the time, but time is distance divided by speed. So the distance 16 divided by the speed of 32 is 0.5. In other words, it's going to take her 30 minutes to get back home. So 30 minutes to get back home, straight down to the origin, and that is that. We are finished. So this is the distance time graph to display that information for rain. Right? That's it. Let's hear what they ask next. It says, from your graph, determine her average speed of the journey in miles per hour. So let's determine her average speed, right? So determine her average speed in miles per hour. So remember, miles is on the y-axis, time is on the x-axis, and the time is in minutes. So remember, how do you find average speed? Average speed is total distance divided by total time. So I'm done. I don't have any space. I don't know why the graph is here. So this is part one. So we're saying the average speed is equal to total distance come on, stop it now, divided by total time. That is average speed. So in that case, the total distance, if we go back up, was well, the total distance, she went 16 kilometers up and 16 kilometers down. So that is really 32 kilometers to travel. And the total time was 100 minutes. But you can't work with minutes. You need to convert it to hours. 100 minutes, you divide that by 60. And so the total time is really 5/3 hours. So now we do the division, 32 divided by our time in hours, and we get this right here, 19.2. So our average speed was 19.2. Why I keep saying kilometers? Her average speed was 19.2 miles per hour. Alright, so 19.2 mph was her average speed. their average speed. Now, the next part want you to work out their average speed in kilometers per hour, right? So in order to do that, what all you have to do is convert. You have to convert now. Oh my, I worked out our speed in miles per hour, right? Now, I hope you would have spot the mistake that I did. This is miles per hour, but they didn't want miles per hour. They wanted miles per minute. So no problem, guys, no problem. Since I had worked out miles per hour, all we're going to do is take off, right? And I'm not even going to edit out this mistake. I want us to see it. That is why it's very important to read the question. As you can see, I worked out miles per hour, but they wanted miles per minute, right? So you have to write down the total minutes, and the total minutes we had was 100. Next time, don't do like what I did. Do what the question asks, 100 minutes. And 32 divided by 100 is 0.32. This is 0.32 miles per minute. Now part 2, it wants kilometers per hour. To go from miles per minute to kilometer per hour, first you have to know the conversion. How many miles make a kilometer? No problem. We don't remember. We need to be able to convert miles to kilometers. Now, usually in an exam, they're going to tell you that 1 mile is equal to 1.609 kilometers, right? How do I know this? I watch a lot of track and field and I remember, all right? But next time they would give you this on the paper, right? So in that case, we can convert the numerator to kilometers. It would be 32 times 1.609 divided by per hour. Now we'll convert the minutes to hours. And 100 minutes in hours is 5 over 3 hours, or 1.67, because we just divide 100 by 60. Then we'll put that in our calculator. So put in 32 times 1.609 divided by 5 over 3. Punch that in the calculator and we get 30.9. So this works out to be 30.9 kilometers per hour. And that's it. Easy, easy, easy. Nice. All right. Now, right here now, right, it gives us this question here and it says, the graph shows the movement of a car from point A to point B is 500 meters from A. Note that there are two slants AB and CD. The slant lines indicate the car is moving naturally. The flat line BC indicate the car has stopped or is at rest naturally. Now it says calculate the speed of the car in the first 10 seconds. No problem. So in the first 10 seconds, how do we work out speed? Speed is distance divided by time. So in the first 10 seconds, the car traveled, in the first 10 seconds, see it here, the car traveled 200 meters in 10 seconds. 200 divided by 10 is 20. So that is 20 meter per second. That's the speed. Now, that's question 1. Question 2 now, it says, for how long did the car stop? How long did the car stop from B to C? It stopped for from 10 seconds to 30 seconds. So the car stopped for 20 seconds. That's number 2. Number 3 now. It says, what is the speed of the car on its journey from C to D? So the speed of the car from C to D. So to find the speed of the car, first thing we need distance divided by the time. Notice that the distance the car traveled, right? It would be, It's at 200 and it go up to 500. So the distance it traveled is actually 300 meters. And the time it takes to cover it from 30 seconds to 60 seconds is 30 seconds. So in that case, we can tell him, so the speed from C to D is equal to 300 meters distance divided by the time it takes, which is 30 seconds. We'll do the division, that is 10 meter per second. Number 4, it says, on which part of the journey did the car travel faster? The car was traveling faster from journey A to B. So we can tell them journey A to. Finally, let's see what they're asking last. It says, what is the average speed of the car? What is the average speed of the car throughout the whole journey? I'm just zooming out so you can see the full question. Let me bring it up, then zoom back in. Alright, so they want, what is the average speed of the car for the whole journey? So for the whole journey, how do we find average speed? Always remember this, average speed, average. So it's equal to total distance divided by total time. Average speed is total distance divided by total time. So in this case now, the total distance is, it traveled what, 500 meters in total? And the time it took to do it was 60 seconds. So we'll do that. 500 divided by 60, which is 8.33 meter per second. So the average speed is 8.33 meters per second. Finally, the last thing, number 6. What is the average speed of the car when it is moving? What's the average speed when it is moving? Remember, for 20 seconds, it was not moving. So you can take out that 20 seconds. So for number 6, it would just be the average speed is equal to 500 divided by, take out the 20, it's not moving, and subtract from 60, leave 40. So 500, instead you divide it now by 40, and you get 12.5. 12.5 meter per second. And that's its average speed when it is moving. Nice. All right, so similar question now. Notice so far we're doing distance time graph. We haven't started velocity time graph yet. But I want you to pause the video and attempt this question. It says, what was the average speed during the first 2 hours? What did the athlete do between 2 to 3 hours? And what was the return? What was the average speed on the return journey? Pause the video and attempt this question. All right, let's go through this question now. It says, what was the average speed in the first 2 hours? So in the first 2 hours, you have to remember average speed is total distance divided by total time. For part 1, right, average speed, the distance divided by time, and the distance it traveled is 12 kilometers, because they told us the unit is kilometers, over time, and they told us the time is 5 hours. So in that case, we do 12 divided by 5. I know many of you know it's 2.2 already, but just to show with the calculator, 2.4. Don't laugh at me, that's fine. So 2.4 is the average speed, and it is kilometers per hour. Alright, that's it, 2.4 kilometers per hour. Let me write a little per hour a little bit better. Now the second part says, what did the athlete do between 2 to 3 hours? So what did the athlete do between 2 to 3 hours? Right here. Between 2 to 3 hours, the athlete rested. So athlete stopped or rested, meaning he was not moving. He was not moving, right? So see there? Notice it stays at 12 kilometers. The average, the athlete was not moving. Part 3. What was the average speed on the return journey? On the return journey going home, right? On the return journey going home, we notice that it takes what? Right here would be 3.5. Just for clarity, that's 3.5 hours. From 3.5 hours up to 5 hours, that's really 1.5 hours. So the return speed, so VR mean return speed, so speed returning home is the distance covered 12 divided by 1.5 hours. Put that in the calculator. 12 divided by 1.5 and we get 8. So that's equal to 8 kilometers per hour. That's the return speed, right? Nice. All right, now another distance time graph. Don't worry, we're going to be getting into velocity time graph very soon. I want you to pause the video and answer this question for me. It says an answer sheet right here, so it gives us this graph, and it says the distance time graph below describes the journey of a train between two train stations A and B. Answer the questions below on the sheet. For how many minutes was the train at rest at B? And then determine the average speed of the train for the journey A to B. So pause the video and attempt. Alright, now as you would have done this, they told us what? At B the train come to a rest. So here is the train. So the train, a train between two train stations A and B. This is train station A right here, so it would be train station B, right? Now, how do we know they told us at B it came to a rest? Now, once it came to a rest, how long did it came to a rest for? From 40 to 60 is 20 minutes. 20 minutes, right? So in that case of a part I, it came to a rest for 20 minutes. That's it. 20 minutes for part I. Part 2, determine the average speed of the train on its journey from A to B. So from A to B, notice, traveled what? 8, how much kilometers, right? It traveled in between 80 and 120 is 100. So since we get the 100 up there now, we can tell them that the average speed, so for part 2, the average speed, alright, stop doing that please. Let me try again. So the average speed is the distance divided by the time, and the distance is 100 kilometers and the time is 40 minutes. But they want the average speed in kilometers per hour, so you cannot divide by 40 minutes. What do we need to do? We need to convert 40 minutes to hours. So first do the division. 40 divided by 60, that is 2 over 3 hours. So it's 2/3 of the hour. It's less than an hour. Now we can do our division. 100 divided by 2 over 3, that is 150. So the average speed is 150 kilometers per hour. That's it. That's part 2. Part 3 now. It says the train continued its journey away from station A and B to another station C, which is 50 kilometers from station B. Then now it says the average speed on the journey was 60 kilometers. Calculate in times taken for the train to travel from B to C. Now we need to calculate the time, right? So notice once it leaves station B, right, what they pretty much told us, we need to find out this time, right? If you're using the graph, you might say it is 110, right? If you're using the graph, you might say it's 110. No problem. But let's say you didn't want to use the graph, right? You wanted to work it out. Work it out, what do you know? Well, we could say, we need to find out this time, right? Right, but we know the average speed. The average speed is 60. 60 is equal to what? The total distance it cover. The total distance, them say was 50. And it need to divide by the total time. And the total time, we need it in what? In hours. Right? We need the total time. Now, Sorry. To work out the total time, right? These are your two critical points, right? So we know that it must be, we don't know this time right here. We can call that time t. Right here, let's call this time t. So it's t minus, we know that right here is 60 minutes, and 60 minutes is what? 1 hour. In that case, now we need to solve for t. So we can flip it to get t minus 1 is 50 divided by 60. So we add 1 to both sides, so t equal 50 over 60 plus 1. That ended up being what? 50 over 60. Sorry, 50 over 60 plus 1. And that ended up tell us that it is 50 over 60 plus 1. And this is our answer in hours, 11 over 6 hours. 11 over 6 hours, but they wanted it in minutes, so you multiply it by 60. You multiply this by 60, and you get 110. So remember I told you, you could have just looked at the graph and said in between it is 110. I wanted you to say how we get the answer by actually doing the computation, right? So it doesn't matter which way you wanted to do it, that's fine. Now the last part, it says, on your answer sheet, draw a line segment which describe the journey from B to C. Oh my, guys, can't you see what I did? Now I see. So when I was setting up this question, I was the one that put in this red line. And I put in the red line, this red line is really should have came in after, right? So that means that you had to actually work it out without having this red line here. Right? So my apologies, guys. I put in the red line here. This red line was not supposed to be here, right? So I put it in first on the graph, and then I put the question together. So that means we have to ignore part 4. So my bad. Sorry, guys. We can't do this because I already put in that right there for us. Now we need to move on to velocity time graph. This is equally important, or even more important. Oftentimes, this is the one that you get tested on, velocity time graph. So notice it says, consider the graph below. Notice the y-axis says velocity and the x-axis is time, right? And it's dealing with athlete during a race. It says calculate the acceleration during the first 4 seconds. Always remember, for a velocity time graph, the gradient is acceleration. Let me say it one more time. For a velocity time graph, the gradient is acceleration. So in doing these questions, right, now all we're going to do is for the first 4 seconds, acceleration is final velocity minus the initial velocity divided by time. The final velocity at 4 seconds is 8 minus the initial velocity at the start was 0 over the time was 4. 8 over 4 is 2, so the acceleration is 2 meter per second squared. That's how we write it. So that's number 1. Number 2. Number 2 now, they say we need to work out what was the athlete doing during the 4th to the 14th second. So from 4 to 14, what was the athlete doing? The athlete was traveling at a constant velocity. Notice the velocity stayed 8. So the athlete was running at the athlete. Alright, my pen gone. So sorry about this. Having some delay. Is it back? Yes, it's back. So the athlete was running with. Alright, since this is giving me so much problem, I'm just gonna type it. The athlete was running with a constant velocity of 8 meter per second from 4 seconds to 14 seconds. That was what the athlete was doing. The athlete was running at a constant velocity. Now, number 3. Number 3 says what? calculate the deceleration in the final stage of the race. Final stage is when the athlete started slowing down big time. So notice the athlete slow down this portion, right? So we need to work out the gradient at that portion. So the deceleration, right? So the deceleration or the negative acceleration is equal to, realize it's the final velocity. The final velocity was 0 minus the initial velocity 8 over the time taken, which is 1. So it works out to be negative 8, but negative 8 is just 8. So in other words, we're telling them the deceleration. So look what we're going to do. We're going to drop off the minus sign and just say the deceleration was 8 meter per second. That was the deceleration. Right? It's negative to show that it's deceleration. The negative indicates it's deceleration. Now, it says question 4. How far was the athlete moved in the first 4 seconds? In the first 4 seconds, to find out how far the athlete moved is the distance under the graph. Let me say it again. To find distance, it's area under the graph. Anytime you have a velocity time graph, the distance is area under the graph. So they need us to find this area for number 4. So for number 4, we can tell them the distance is equal to half base times height, because that's just a triangle. It's half the base is 4 times the height, which is 8. That is 32 times a half, and 32 times a half is 16 meters. And that's it. Easy. Number 5 now, what is the total distance traveled by the athlete? The total distance traveled by the athlete is the complete area under the graph. The complete area under the graph, right? Complete area under the graph, we're going to realize that this is a trapezium. Area under a trapezium is half a plus b times h, where a and b are the parallel sides and h is the perpendicular height, right? So in that case now, a is this distance from 4 to 15. From 4 to 15 is 11. At the bottom is 16 and the height is 8. This is half of 11 plus 16 times the height of 8. Put that into our calculator. So half of 11 plus 16, and then we multiply it by height of 8. We do that and we're getting 108 meters. So this athlete is what? Very slow. Imagine you take 16 seconds to run 100 meters, 108 meters, that's very slow. Because we know athletes should be taking 11 or 10 seconds to run 100 meters. So very slow athlete, but that's fine. Right? We're not troubling this athlete. That's okay. Let's do another question. Alright, so this question gives us the speed time graph below, shows the journey of a car from 8 a.m. to 11 a.m. You need to use the graph to answer the following question. So I want you to pause the video and attempt the question. So in doing this question now, right, first thing they want was the time at which the speed of the car was 40 kilometers per hour. Right, just the time at which the speed was 40. So we have to use dotted line and look when the speed was 40. The speed was 40 at this time, right? At this time, the speed was, I'm using my dotted line. Now let me go down. The speed was 40 at this time, and this time would be, this is 10 o'clock and this is 11, so we're going across, how many, what's the division? 1, 2, 3, 4. 1, 2, 3, 4. So each one is 15 minutes. So this is 10:15, 10:30, this is 10:45. So for part one, that is 10:45 a.m. This is 10:45. Next part, it says we need to work out The distance the car traveled for the entire journey. No, no problem. The distance the car traveled for the entire journey. First thing, distance is what? Area under the graph. How many times we're going to say it? So we need the entire area under the graph. Now this again is a trapezium. How do you find area of the trapezium? It's half the sum of the parallel sides multiplied by the perpendicular height. So it's a half. This side at the top is, what's the length of that? Right? So really and truly the bottom, right? Really and truly down by the bottom, the length is, it's 3 hours, right? So up here, if the entire thing down here is 3 hours, at the top, what is this now? At the top, this would be dotted line come down. I want to make sure I getting it right. This is 2, this is 2.5. So up here is 2.5 hours. So it's a half 2.5 plus 3 multiplied by the height, and the height is 80. Punch that into our calculator. Half 2.5 plus 3 times 80. And we get 220. That is it. So we get 220. And so that is the distance. 220. Stop doing that, man. So that's the distance. Now part 3 now, it wants us to find the average speed. Now we are so accustomed to average speed. Average speed is total distance over total time. Total distance divided by total time. Now the total distance is 220 divided by the total time, which is 3 hours. You put that in your calculator, it cannot get any easier, which is 73.3. This is 73.3 kilometers per hour. That's it. 73.3 kilometers per hour. Very easy. Nice. And guys, the final question of the day. So, pause the video, attempt the question. This is a CSEC past paper question now. Do this for me, please. Pause the video and do this question. So this question, it says, the diagram below shows the speed time graph of the motion of an athlete during a race. And it says, using the graph, determine the maximum speed. So using the graph, determine the fastest speed it reached. The fastest speed the athlete reached was 12 meters per second. So part 1 is straightforward. 12 meters per second. Good. Part 2 now, it says the number of seconds for which the speed is constant. So we need to look where we say horizontal line, where the speed is maintained. The speed is maintained right here. So from 6 seconds to 10 seconds. So the number of seconds the speed is maintained, 4 seconds. That's it. Notice how easy that is, 12 meters per second, 4 seconds. Now part 3 says work out the total distance covered by the athlete during the race. Total distance. So part 3 now, this is the tough part. Again, guys, this is easy, total distance. Total distance is equal to area under the graph. Anytime you get a velocity time graph, area under the graph gives you the total distance. So the total distance S is a half A plus B times H. So this is a half of A parallel sides. At the top up here is 4. The whole time is 13. And the perpendicular height is 12. Right? That's it. So I have to remember how a trapezium look. Let me draw it up here. This is a trapezium. Right? So this is A, B, and the perpendicular height, that is H. That is a trapezium. Then you use this formula. That's all. So now using this formula, I'm just going to take out the calculator. A half 4 plus 13 multiplied by H, which is 12. Bam, 102. So this is 102 meters. So this another slow athlete again. 13 seconds to cover 102 meters. Now it says during the time period of the race, when was the speed of the athlete increasing? So that part is easy. Realize the speed was increasing where? I'll do that on the next page. Where was the speed of the athlete increasing? It was increasing right here. Notice it went from a speed of 0 up to 12. So it was increasing in the first 6 seconds. So this is the first 6 seconds. So let me just label it then. Part 2, Part 2A. Alright guys, this is what I can't bother with the mouse sometime. So I'm just going to have to text it. So the speed was increasing in the first 6 seconds. Done. Bam. Now part B now. Part B now, it says when was the speed of the athlete decreasing? The speed of the athlete was decreasing from 10 seconds to 13 seconds. From 10 seconds to 13 seconds. And then now finally it asks, when was the acceleration 0? Acceleration is gradient of speed time graph. Now when was the acceleration 0? Like you're just not going any faster, your speed buck. So the speed buck here, the speed buck from 6 seconds to 10 seconds, right? So that is when the acceleration was 0. So we can tell them for part C, from 6 seconds to 10 seconds, the athlete speed was maxed out and thus the acceleration was 0. Don't worry, I'm going to make you see everything. Let me edit it out. Thus the acceleration was 0. So once you reach maximum velocity and you're holding your maximum velocity, you cannot go any faster. And so therefore, that is when the acceleration was 0. And so that covers all the different various questions they can ask you on speed time graph and distance time graph. I hope this video was helpful. Just make sure to like this video, to subscribe, and stay tuned for more. Have a blessed day.